Hi everyone, do you know there are two kinds of forces acting in a molecule? Yes, they are called intramolecular and intermolecular forces. But how they differ? So let's go through this example together. There are two different handkerchiefs, color green and orange. We are given a sewing needle and red thread to sew the green handkerchief to the orange one. After sewing, we now have a pair of handkerchief. Imagine, now you have the same three pair of handkerchief. The next step is to attach these three pairs of handkerchief to each other by using a Velcro. Now, what will happen if I ask you to pull the assemble from both ends? Yes, the Velcro will fall apart, while the sew junction will stay as it is. The attachment created by the Velcro is much weaker than the attachment created by the thread. Just imagine the handkerchief to be hydrogen and chlorine atom. These atoms are bonded together by intramolecular forces called covalent bond. Do you remember the handkerchief? The intramolecular forces are analogous to those sewed threads. In contrast, each hydrogen chloride molecule is bonded to the neighboring hydrogen chloride molecule through intermolecular forces called van der Waals forces. These forces are analogous to the velcros of handkerchief. The van der Waals forces can be classified into two, the London forces and also the dipole-dipole forces. Non-polar molecules are molecules that share electrons equally in a covalent bond, where there is no net electrical charge across the molecule. The electrons are evenly distributed. Example of non-polar molecule is Cl2. At any given moment, the electron distribution may be uneven. It will result in an instantaneous dipole. This temporary dipole will subsequently influence the neighboring chlorine atoms through electrostatic attraction and repulsion. It will induce a dipole on a nearby chlorine atom. Dipole-dipole forces are the attractive forces that occur between polar molecules. A molecule of hydrogen chloride has a partially positive hydrogen atom and a partially negative chlorine atom. In a collection of many hydrogen chloride molecules, they will align themselves so that the oppositely charged regions of neighboring molecule are near with each other.